Welcome to The Explainer. So, I was digging into the recent evolution of AI lately, and I stumbled on this completely fascinating shift. For the past couple of years, we've kind of just thought of AI as a solo actor, right? A single chatbot that you prompt and it responds. But actually, scratch that. We are rapidly entering the era of collaborative AI teams. We're talking about multiple, highly specialized agents working together to solve really complex problems. But here's the catch. Teaching these new AI teams to actually collaborate is incredibly difficult. And honestly, they are currently making some very human mistakes. Okay, let's dive into this. Take a second to let that number sink in. Recent empirical analysis of multi-agent AI systems reveals that across agent communications, there is an average knowledge duplication rate of 47.3%. That means literally nearly half of the computing effort, the reasoning, and the knowledge retrieval happening inside modern AI teams is completely wasted. It's totally redundant. They are just duplicating each other's work. So to understand why this massive inefficiency is happening in the first place and how researchers are finally solving it, we first need to look at exactly how these AI teams are being built.
Section 1, the era of AI agents. We've officially moved way past simple prompt and response chatbots into true autonomous systems. Looking specifically at how the semantic kernel framework structures this, an AI agent isn't just a language model anymore. It's an entire architecture combining three absolutely critical capabilities. First up, reasoning. It actually understands context and plans out its actions. Second, tool use. It executes functions to interact with the outside world, like searching the web or querying your database. And third, memory. It maintains its state and remembers context across multiple interactions. You put these three things together, and you get a system that actually takes autonomous action.
Now, what happens when one single agent just isn't enough firepower? Well, you build a team. Using frameworks like Semantic Kernel's agent group chat, developers are grouping these specialized AI agents together to basically mimic a human corporate structure. Imagine a content creation team for a second. You have a researcher agent whose sole job is to find accurate information and cite sources using web search tools. Then you have a writer agent who takes all that research and crafts engaging content. Finally, an editor agent reviews the whole thing for factual accuracy and style, sending it back for revisions until it's perfect. On paper, this kind of specialization is brilliant. But in practice, there is a huge hidden flaw.
Section 2, the multi-agent redundancy problem.
Now, what's really interesting about this slide is the stark contrast between our utopian expectations and the messy reality. When you put all these brilliant autonomous agents in a digital room together, things absolutely do not go smoothly. The utopian vision promises hyper-efficiency, seamless collaboration, and incredibly fast execution. But the reality, it's kind of chaos. Agents are constantly stepping on each other's toes. Because they operate autonomously, they suffer from duplicated knowledge retrieval, overlapping reasoning paths, and misaligned task division. They're essentially a team of brilliant employees who absolutely refuse to communicate about what they are actively working on.
And this brings us right back to our villain data point. When we break down that 47.3% duplication rate, we see it happening across three distinct layers. First, memory redundancy. This is multiple agents independently wasting compute power to retrieve the exact same piece of knowledge. Second, reasoning redundancy. Agents going down the exact same logical inference paths without realizing a teammate has already drawn that exact conclusion. And third, task redundancy. Overlapping subtask assignments where two agents are secretly working on the exact same problem. It is just a massive, massive drain on computational resources.
Section 3, orchestrating the AI team.
So how in the world are developers trying to fix this? Right now, they're mostly applying clever band-aid solutions. In the semantic kernel framework, developers use explicit orchestration patterns to basically force these agents to behave. It's essentially the AI equivalent of middle management. You have the supervisor pattern where one specific agent acts as the boss, taking the user's request, delegating it to specialists, and reviewing their work. Then you have the debate pattern where you might instruct one agent to be the optimist and another to be the skeptic, forcing them to argue different perspectives while a moderator agent synthesizes the results. And finally, you have the specialist router, which acts like a dispatch system, routing user intent to the correct department.
While these orchestration patterns are definitely helpful and for sure better than a free-for-all, they don't actually solve the deeper structural problem. Research shows that these systems still rely on fragmented designs. The task coordination, the reasoning execution, and the memory retrieval are treated as completely independent, disconnected components. A supervisor agent might assign a task, but it has no idea how the specialist is reasoning through it or what memory they are retrieving. That fragmentation is the root cause of the massive inefficiencies we're seeing today.
Section 4, the D³MAS solution. So what if we didn't just add more middle management, but completely re-engineered how AI teams collaborate from the ground up? Enter D³MAS, which stands for Decompose, Deduce, and Distribute. It is a brand new, hierarchical coordination framework that solves this redundancy problem not by telling agents to just talk to each other more, but through sheer, brilliant structural design. It builds what's called a unified heterogeneous graph, which is basically a highly structured web of connections that explicitly organizes how information flows across 3 specific layers: the task layer, the reasoning layer, and the memory layer. And this brilliantly illustrates exactly how this rule of 3 works, using concepts we easily recognize from our own workplaces. First, decompose at the task layer. Instead of uncoordinated splitting, the system builds a crystal clear task dependency tree, breaking the project down into minimal subproblems so everyone knows exactly who is doing what. Second, deduce at the reasoning layer. By explicitly mapping reasoning dependencies, agents can essentially read a coworker's conclusions, bouncing ideas off each other without repeating the exact same logical inference paths. And third, distribute at the memory layer. Instead of everyone Googling the same facts independently, agents access a distributed, non-redundant shared company drive, pulling only the exact knowledge needed for their specific subtask. The real magic that glues all of this together is called hierarchical message passing. Information flows bidirectionally here. It's a top-down and bottom-up flow. The top-down task requirements actively guide what memories are accessed, filtering out irrelevant data before it's even retrieved. Meanwhile, bottom-up feedback from the reasoning layer can dynamically refine how tasks are decomposed on the fly. This guarantees that the system shares the absolute minimal, yet entirely sufficient, information required to get the job done. No more overlapping tasks, no more duplicate reasoning, and no more redundant memory pulls. The whole shebang is finally synced up. Section 5. Future of Collaborative AI. So does this structural overhaul actually work in practice? Absolutely. When put to the test across really challenging empirical benchmarks, the D3MAS framework successfully slashes the average knowledge redundancy rate by a massive 46%. By simply restructuring how the agents relate to one another, nearly half of that wasted effort is instantly reclaimed. But it doesn't just make the system cheaper and faster, it actually makes it significantly smarter too. So the crucial point is this massive jump in capability. When tested on the incredibly rigorous MMLU benchmark, which covers complex logical reasoning across 57 different subjects, previous state-of-the-art multi-agent baselines like MACnet scored about 68.8% accuracy. D3MAS pushed that accuracy all the way up to 85.3%. That is a monumental leap in reasoning capability. It proves that when agents aren't distracted by redundant tasks, they can collaborate to solve much, much harder problems. And we see this trend across the board. In coding tasks, specifically the human eval benchmark, D3MAS boosts accuracy from 72.6% up to an astonishing 89.8%. But honestly, perhaps even more impressively, it introduces incredible resilience. If an agent fails or if memory gets noisy and introduces bad data, traditional vanilla agent teams see their accuracy absolutely plummet to 45%. But because D3MAS relies on distributed memory and a rigid dependency structure, it maintains an 80% accuracy rate even under adversarial, highly chaotic conditions. We've seen today that the secret to unlocking the true power of an AI team isn't just making individual agents smarter, and it definitely isn't just forcing them to talk more. It's about designing a brilliant, transparent structure for tasks, reasoning, and memory to flow perfectly between them. Which leaves us with a totally fascinating question to ponder as we close out. If AI agents are learning to collaborate flawlessly by eliminating redundancy and embracing transparent, structured hierarchy, what can human teams learn from them? Thank you so much for learning with me today, and I will catch you in the next explainer.